So for lab one, I have to demonstrate the three softwares that are required for this class. As you can see here on my desktop, I have AutoMod, SassJump, and MATLAB. I'm now going to run each one of them. So here is my MATLAB application. Here is my Jump application. And finally, here is my AutoMod application. So to fully understand and successfully complete this lab, I had to read chapter 1, which is the principles of simulation, from the book Getting Started with AutoMod. This chapter defines what a simulation is, and it gives you the example of an ad hoc simulation, which you'll see soon, something you can do in Excel. Their example uses a mechanic. The one I used is going to be dealing with tools. But basically, this chapter goes into the definition of a simulation, the different types of modeling concepts, and then the advantages and disadvantages of simulation. But this example I'm about to show you kind of just displays how applicable that simulations can be in the real world. So here in Excel, I created a simulation for persons arriving in a tool room. As you can see, the first column lists the 20 people that arrive in the system, 1 through 20, to simulate the tool room service process. The inner arrival times need to be randomly generated, and here you can see they're randomly generated between 1 and 10. Over here in the arrival time, you're just going to add the previous arrival time with the inner arrival time. So as you can see here, this 10 here is added by the 0, and then the 10 in the inner arrival time. You also see the 10 to 9 added to be 19 here in this arrival time. So that's how you get the arrival time. You then have length of service time, which is a randomly generated number between 1 and 6. From here, you'll have the time service begins, which will start at 0, similar to the arrival time. And then you'll have time service ends, which is just the time it begins plus the length of the service time. So as you can see here, 14, you get that with 10 plus 4. And moving on, we now have time and system, total crib attendant idle time, and then tool waiting time. So yeah, do another simulation here. As you can see, the numbers will change. Down here we have your average time and system, which is calculated by your total time and system divided by the number of persons. So here it is 72 divided by 20. So you have an average of 3.6 minutes. Your percent idle time, which is calculated by the total idle time, and then the time service ends. You also have your average wait per tool, and in this case, the total time is 0, so your average wait is going to be 0. And then your tools waiting, so any number that's greater than 0 will be counted, and you'll have that frequency of tools here in this column. And then your average wait, if the tool is waiting, so it'll take that count and then divide it by the number. So your total wait time is then divided by the number of tools that are actually waiting. And as you can see in this example, there aren't any, so it's just 0. But yeah, that pretty much summarizes the tool room simulation. This is based off of the example 1.1, the ad hoc simulation table from the book. I hope you enjoyed this demonstration. Have a good one.